Aha, you are live. Hello.
Nice.
Um,
Hello.
what are you building?
We are building a protocol for discovery. Basically, that's in general. If you think search engines, these are discovery tools. Online marketplaces, they provide discovery functions. Dating apps, everything you experience on the web, it's mostly tied with discovery. And thanks to decentralized technologies, uh, we believe there should be a protocol for discovery. And this idea has been forgotten for the last 35 years, was included in the initial idea of the web. But yeah, finally, we are building a protocol for discovery.
So, was it really forgotten? Because I know, and maybe this is a semantic thing. Oh, I shouldn't have used that word. Maybe I always make accidental puns, but like around the early 2000s, there was this idea of the semantic web, and some people even called it Web 3 at the time.
Yeah,
After the Web 2 explosion. Um, there were discovery oriented things built into that too, right? And sort of like protocols in terms of at least data interchange formats. Like we had various flavors of RDF and we had
yeah.
OWL for ontologies and those sorts of things.
Yeah.
Is that the sort of protocol you're talking about? And are you trying to solve the same problems as the semantic web?
Problem is the same, but discovery protocols even earlier than that. If you remember Gopher, even there were another protocol, Archer. These are distributed search protocols in the early days of web, maybe like 30 years they started. Because discovery at that time, they neglected to solve that problem. They just forgot to solve. Here we are. Then semantic web, like it was in the initial paper of the web, but RDF was a huge paradigm, like it's an actual model for semantic web. It didn't happen it's actually happening, but in different ways. RDF is basically guided a lot of technologies. Itself didn't happen, but everything we see in the semantic technology on the web is basically inspired by RDFs.
Okay, cool. So at least I know that my 20-something-year-old knowledge isn't completely useless in this conversation.
Yeah,
Um,
all through.
and I was a Gopher user. That's how I got addicted to the internet, which I
Wow,
guess most people who are
amazing.
still living aren't can't say. um, so let's get very concrete as soon as possible. Then we can back up to the abstract stuff because I think saying something like a protocol for discovery is such a high level idea that
Mhm.
it's hard to figure out what that means. So, what concretely are you going to build to implement this?
Exactly. So if you're thinking discovery from the technology perspective, let's say search engines. Typical search engine has two components. You have an index and you have an algorithm. Google index, Google algorithm, right?
Mhm.
All these discovery architectures has these two fundamental components. And usually these are monolithic, and that's why we call them search engines. These are very monolithic concepts, and they promote and they limit us by, for example, their scope of index. For example, they index sort of things. They might not index and other things. So that's the first bias. And then there's like very popular bias, algorithmic one. And if you think like Google for the last 20 years, we optimize the whole world's knowledge according to just one single algorithm. We have just created industries to optimize for one single algorithm.
And when you talk about algorithm, you mean like the retrieval algorithm. So
Yeah,
once you do a search, what gets returned and in what order?
exactly. In the beginning, for Google, it was famous for PageRank, for example. So what is a protocol for discovery? How do we make a protocol from this architecture? We borrow the architecture, index and algorithm, but this time we transform these components into networks. So instead of single index, we say there should be a network of indexes, and these indexes should be composable and owned by different entities, like companies, organizations, individuals. But instead of single, there should be a network of indexes. That's on the left side. On the right side, for the algorithm part, we say, like, for example, in search systems, you have a relevancy concept. But we say relevancy should be also a product of a network. So instead of single algorithm, there should be a multiple algorithms that competes for relevancy. So multiple autonomous agents are competing for relevancy. That makes a protocol for discovery.
Interesting. So, like, you could literally rebuild just what looks like a search engine on this, but you have decentralized collaborative actors out in the world creating new indices, and then you have competing algorithms to generate the best search results off of these indices. Yeah,
absolutely. Yeah,
interesting. Yeah,
and again, what is best? If you indexes started to solve discovery problem in journalism 8 years ago, the initial idea, I would be like, I want to discover different perspectives for a given topic, because in journalism, best or truth is a perspective issue. You know, what is true, what is real, and what is right. These are very perspective concepts. If you think e-commerce, what is best is decided by competition. It's another factor here. It's not an algorithmic thing. We have to compete for that one. So the truth and relevance is a very complex thing. It has different dimensions in it. We should accept that. We should accept one model won't solve our problems. We should accept discovery should be freed from this single model, and itself should be decentralized. I think it's the biggest bottleneck in our web right now.
Fascinating. Yeah, and you know, I use the search engine example because you had, and it's probably the most obvious one. But I get the sense, especially when you talked about autonomous agents, that your definition of discovery is much broader than user going to a website and searching for something and getting results. Yeah.
Yeah, absolutely.
So what are some of the other use cases? Like, is this interesting now to you because of agents, because of the idea that you have the potential for autonomous agents that might want to discover and surface and maybe even act on things, or you know, like, what are the boundaries of how I should think about discovery in this context?
For me, it's everywhere. It's like a obsession. So whatever I see a discoverability problem. But let's say autonomous agents. So it's a very good concept nowadays. It's a very old concept, but yeah. So how these agents are going to discover themselves, for example. Let's say I am an agent, I am capable of doing one task, and there's another agent capable of doing another task. And if we want to collaborate, first we should be able to discover each other. So discovery for autonomous agents, that's one use case. Second, discovery, scientific discovery is the most valuable part of discovery, right? Like we are finding cure for diseases. If you think autonomous agents are competing for finding cures, for finding scientific knowledge, that's another approach for discovery. Dating apps. I think that dating apps is also has an interesting place because we are limited by their filters. The whole human species now using these apps to match, but they only have kind of filters. These are very structural form of finding each other, and very limiting. And I think it's also affects on human diversity. You know, it's a very dangerous thing to use these limitations for these kind of serious things. Other use cases, like
I want to back up to that one just because it's so much more disturbing than I realized when you start talking about it that way. Because again, I'm a person who used Gopher, which also means I'm a person who got married before there were any online dating apps, I think. So I've never experienced that. And I realized that almost everyone else, at least in the like developed Western world, is 100% using dating apps to find each other. That's how they do it, right? That's how young people do it. And if that's the case, then bias and centralization in algorithms literally could have evolutionary effects on the species.
Absolutely. So we should not be doing that. We should be, at least like, it should be decentralized, maybe the first thing, dating apps. I think, than e-commerce, than the others. But yeah, it's also disturbs me a lot. And yeah, absolutely.
Well, maybe we should look at something to make it more concrete, because
Mhm.
we've gotten into evolutionary disaster for the human race, so we probably need to get back down to something concrete. Do you want to show the application that you're building? It might give people a good sense of what's happening beneath it.
Of course.
Okay.
We also have an app to demonstrate what is possible. And right now, I'm sharing my screen. So index network, you connect with your decentralized identifier, and this is your identity, belongs to you. And then after you connect, anyone can create an index. Let's create an index, for example, for Blueyard. And here we are. We just create an index on a decentralized knowledge graph. We use Ceramic Network for that. It's a decentralized data layer. It's a knowledge store layer. And you can index basically anything. You can add PDFs, web pages, products, and different social graph items, casts, tweets, any kind of model, data model can be indexed. What do we mean by indexing? So if I add, for example, this link, let's add, if I'm adding this link, then first we are crawling this link because this is Web 2 content, then storing on decentralized knowledge graph. Then when it's available, 5 or 10 different agents are starting generating vector embeddings according to their preferences. One agent generating embeddings for OpenAI, the other one is generating for Cohere. So different vector embeddings, different models. So it's already interpreted by different perspectives because each model is a different perspective. So under your index, basically agents are attacking your data to understand it better. So what you can do,
when you say that they have different perspectives, like you're talking about literally probably the same code calling out to multiple embeddings, embedding models.
Exactly.
And just whatever bias is inherent in those embedding models is the diversity so far, right?
Yeah. Absolutely. So what we did, here we are, we can, for example, set conversational setup. We can chat with it. As you see, there are multiple indexes. For example, we index our documentation. This is our documentation index, our blog. There are indexes for social graphs, like Farcaster graphs are being indexed. There are indexed for reputation data on Web3. These are attestations. And there are indexes for news graph, paragraph publications. So multiple graphs, multiple data sources, multiple data sets can be indexed. And as a user, what can I do? As you see, I start that other indexes that belongs to other people, and I also own indexes. So let's test it. If I say, what is index network? All right.
So here you're searching across all of the indexes that you have in your account here.
Yeah.
Right. Yeah.
So most probably, we just compose responses from these two indexes. We just compose multiple knowledge graphs.
Mm-hmm.
And the second, if you say, for example, I am curious about this, now things are getting funnier because another autonomous agent is detecting our intent. Sheref is curious about this, the whole context. So basically summarizing that context and storing on the intent graph. Intent is a human-centric graph and allows multiple autonomous agents to discover what we are looking for, what we need, what we are curious about. And one agent just picked and selected, in quotes, you are usually talk with most relevant agent. We don't know which agent you are talking with. It's most relevant agent. Over time, competition will be applied. So it says, I'll keep you updated about future updates. So let's test it. I'm going Warpcast, and here we are casting these news.
So this is the Warpcast client for Farcaster you're looking at now.
Yes. Yeah. Farcaster is the decentralized social graph. And we just cast these. And another autonomous agent will index it and another agent will check its relevancy to that composed context here. So if it's relevant, we should be seeing a real-time notification. If not, we won't be seeing anything. Hopefully, we should see something. 3, 2.
If we don't, it's just because it's a demo, and demos are made to fail. Right?
Yeah, unfortunately. Let's try again. Yeah, but usually it says, I found a new update. And what you do, you just compose multiple knowledge graphs, an intent graph, and social graph. Like if you get a real-time notification about it. So
right. And you don't need the social graph, right? That's what you're saying. That's what we just did. But like,
yeah.
Let me now ask you some questions, and I bet while I ask you the questions, this is going to.
Here we are. I just pressed. Yeah, it was working. So yeah, like knowledge graphs, intent graph, and social graph. So that's the definition of composability from our perspective. And again, let's think another approach, another aspect.
Let me ask you some questions before we move on, because I already have a few. So I have too many questions, in fact. All right, so you have a knowledge graph, and actually it's multiple knowledge graphs. Each index, you said, ends up creating a knowledge graph in here somewhere, right? Is the idea that all knowledge graphs are vector embeddings, or is there something more akin to what you would get from like RDF, where you're literally like creating a taxonomy or an ontology and plugging things into some schema, you know?
Great question. Great question. I have multiple answers to that. The first, for example, Farcaster is a social graph. It already has data with its semantics. It has relations, the author, the cast, the channel, different. It's already embedded on the knowledge graph. So then we store vector embeddings on the same graph, on the exactly same graph. So if you store vector embeddings on the same graph, like you achieve different kind of interoperability. It's called semantic interoperability. The first layer of interoperability we know about is a technical interoperability. It's in blockchains. It's a very very common term. But if you embed semantics on the same graph, now you have semantic interoperability. It's a very important thing because usually we interact data with its meaning. It's all about if we lost the meaning when interacting the data, we have to construct that meaning with semantics each time in our minds. So if you don't lose the meaning, if you store the meaning the same graph, basically meanings is carried by vector embeddings because they can carry meanings under just one AI model. So that's a very efficient way of storing semantics and retrieving semantics. Yeah, that's one thing. The second part, the knowledge graphs, like how do we construct knowledge graphs? Because the data is always corrupted, data is always missing something, missing attributes. Let's say at these different knowledge graphs, for example, how do you compose different knowledge graphs? Because these are very these are different graphs. You know, like they have different distributions, different schemas, different data characteristics. Usually, we cannot even relate things. Even like, for example, in science, you actually don't know these relationships. In science, the essence of science, you don't know. So how do we construct? How do we find composability across graphs? How do we compose basically graphs? We think it's where the index network solves the problem. We say agents can also mine these relationships, construct these relationships, can compete to find these relationships between multiple knowledge graphs. All right, I have a social graph, I have this attribute. On the different graph, I have this attribute. Maybe these are relevant. Maybe I should find these relationships. Okay, then I found it. Maybe I should index these relationships in a generative way. And then this index will be discoverable to other agents. So maybe it's useful, other agents will use it. So indexing is basically finding these missing known or unknown relationships and make them discoverable to others.
Mm-hmm. So I'm going to contrive an example. Maybe I'm indexing. Let's say everyone uses Farcaster for everything, right? Just to make it simple. So I'm indexing Farcaster or some social network. I'm getting all this raw text, and of course I have a social graph which has a real structure that's defined and has a schema, so you know like who I follow and when I like something and all these things, right? But maybe I've decided that I can come up with an algorithm for indexing where I can tell if someone likes Taylor Swift. And so I could create my own index just based on people's behavior that tells you whether or not someone likes Taylor Swift. Yes. I don't know why I chose that. It's a stupid example, but then this would be an index that exists, which might be complete nonsense because I might decide that if you ever use the word Swiftie, then you like Taylor Swift, which could be wrong. But then my index just competes and it sits out on the network, and either people use it or not because they find it useful or useless. Is that right?
100% right. It's the perfect example.
Cool. So then I could use that, and I could compose it with like this person's GitHub profile, and I could write an app that shows me all Python developers that like Taylor Swift.
Absolutely.
Or alerts me every time a new Python developer shows up in the world that seems to like Taylor Swift.
Yeah. They're already at very complex points, Taylor Swift, Python, and the states. So you already compose different graphs. Yeah, absolutely.
Cool. Yeah, and I was seeing, like, when you were showing the example, you mentioned Farcaster, like a social graph has a structure, it has a schema. It's not just raw text. You also showed like ZK Pass attestations. So my assumption is the underlying index there that someone would have created for that literally makes the connections that say, assuming this is how that works, this address attests to something about this address, and it's just a bunch of assertions.
Absolutely. I want to show something.
Okay.
So this part is very interesting. So Web3, we are talking about Web3, and usually the definition also carried by semantic web we talk about. But there is no, like, semantic web is actually started in Web3. Is like in Web3 there are at least 60, 70 different protocols for identity. There are protocols for intent, mostly in DeFi. There are protocols for trust, reputation, even for intuition. And semantic web actually started by building its parts. All these protocols are semantic entities. All these are contextual entities. And we usually use them together to understand things. Identity is highly tied with reputation. Reputation is knowledge is connected with reputation. And trust is very connected to knowledge. So these are all required together. You should be using together to understand things. And exactly. So that's why we index reputation data. We started experimenting. And we think all these should be discoverable together. That's like we showed in 3 graphs in here. So very soon, you'll discover things with its reputation, with its trust, with its value. For example, there are value protocols like prediction markets, especially in competitive context. It will be very important. So all these protocols will be discoverable with a discovery protocol. That's the ultimate mission we want to achieve.
Yeah, I'm glad you brought the protocol word back in, because we're looking at an example here, right? We're looking at an application that you wrote, and it's sitting on top of at least the nascent version of this protocol suite or create protocol. I don't know the right way to say it, but it is just one user interface. But you're highlighting some pieces here that appear to be in the protocol. So, for example, there is a network of indexes. If you didn't have that, then the name of your project would be kind of silly, I guess. But there's a network of indexes or indices. There are potentially networks of some sort of node that can retrieve data from these indices. Like, what are the pieces of the protocol, and what are the specific things that you've built here that are just part of the demo? You know what I mean?
Yeah, exactly. Maybe I can show the architecture diagram. It might helpful.
Yeah, that'd be good.
All right, here's my architecture overview. I think it's gonna help. So super quick, I'm going to focus on, like, we should focus on privacy in the coming minutes, but we think, again, like in the previous, we mentioned about composability, but we haven't mentioned privacy yet. Privacy is also another aspect of user-centric discovery, because when you think, for example, let's say Google example, everything is public, so you compromise your privacy for the sake of discoverability. And it's a big compromise, because that means private data cannot be discoverable by others. And that's just simply wrong, because private things can be also discoverable, basically. That's privacy part is very important for discovery. Private data should be also composable with public data. For example, let's say you created a private index, and this index should be composable with public graph. Let's say like my company index, and you can say, let me know if someone mentions my things relevant to my company on Farcaster. So the privacy is a very important part. We should talk about it, but it very affects the architecture of index. So the first part for storing secrets, for you, like you own your indexes, we use LIT protocol to manage access control, the secrets. It's basically a multi-party computation network, and like to achieve privacy with blockchain-backed way. So that's one part. So you create index, your index is basically controlled by LIT protocols, PKP. Okay, let's focus on the data layer then. I just talk about privacy a lot. So when you create an index, you store this index schema, index model on Ceramic network. Then when you add an item to index, you store the item on the Ceramic network as well. So let's say index and a web page. Then another agent is generating vector embeddings, and we store vector embeddings on the same graph. So these are our data layer. Okay.
Who is you in this case? So you say like when you create an index, are you talking to me as a developer who wants to create his own index on the network with my own code?
It's for us, it might be a developer, it might be a user, but like directly users. But index is a user-centric protocol, and we think users will have will know what their indexes are. Like apps shouldn't be preserving indexes to, like, it's not a basic developer tool. Indexes are privacy containers. Indexes are contextual containers. So you should know what kind of indexes you have. So ideally, it's a new kind of data format. So ideally, we want users to be aware of their indexes. But
right.
Of course, a developer can facilitate all these processes. Exactly.
Okay, that makes sense. So you're really talking about like you as the user who was in, for example, the web app putting the blueyard.com URL. And the reason my brain went to developer is if it's something more than scraping content off of a web page or some text dump, then you need to have more programmatic access to the thing that you're indexing. So for example, if you're going to go index Nostr, the social network, you need to program something that is aware of Nostr and the graph behind Nostr and create the indexer for it, right?
Absolutely. For public graphs and public data, I am the developer. I usually integrate index. So other developers will integrate indexes. In science, things are a bit different. Science user centricity becomes less important. So maybe things works in different way here, but like the composability works again. Index will be discoverable then. That too. Yeah. So the user, developer, the actor, our actor, the index creator, then created index. So they own their index with blockchain-backed data ownerships thanks to Ceramic network. Then what we should do, So we should be able to do vector search on this user-owned data and possibly private data. So how do we do vector search on this knowledge graph? That's a tricky one, because the search and discovery is a very sub-second latency you need privacy. So we evaluated all different architectures and for search and the database to build a database actually. And it functions as a database, and we end up by using Fluence network to run these search nodes. So when you create an index, you basically provision a new search node on Fluence network. So this node is trusted by you because you own this node. And if you need specific privacy needs, for example, you can schedule a trusted execution environment node. Then your data is being decrypted in this node and becomes available for vector search in subsequent queries. It's basically your own search node. So for public graphs and for your user-owned graphs, you have your search hot query service. So this is the data layer. This is the search service. Then maybe I can focus on the agents part, because it's also very tricky. Because how do we enable people or agents to interact with our data, with our intents, with complete privacy? That's my background is advertising. I spent a lot of years in advertising. It might be only industry where intents, privacy, distributed systems, and AI combined. And privacy is a very important concept there. But when you increase the privacy, when you promote privacy, you usually end up with algorithmic plurality. It's a very these are very opposing forces. How do we enable multiple algorithms to interact with our intents with complete privacy? That's the problem for index network to leverage decentralized technologies. And we also
and the user-facing problem there is the more you increase privacy, the less intelligent the algorithms can be ultimately, and therefore your experience is not great. If it's advertising, it means you're going to get advertised the same thing everyone else does, which isn't a very effective way to do advertising. And if it's search, you're going to get the same search results everyone else has without any sort of personalization, right?
Exactly. So, and again, in science, super quick, very privacy aware industry science, but we need multiple algorithms to process scientific data. Right? So that's different industries. Privacy is we couldn't compromise any of these. So how do we achieve one? So thanks to blockchains, we can distribute trust. So that's a huge advancement. So we could design systems that accordingly. So what we do, just as we provisioned our search node, now we provision agents in user-owned containers. So now agents are run by per user containers. So that means the code will be owned by other developers, will be attested by other developers, so trust will be visible, but the runtime will be owned by user or trusted by user. So that means there won't be any data leak, and the runtime, your data, the processing environment will be isolated just for you in a user-owned containers. That ensures trust in a decentralized way. And yeah, so that's how it works.
So let me ask you about that piece then. Does that mean I have to run, I think the answer is no, because it says Fluence network on it, but does that mean I have to run it on my own computer? Or can I run it in the cloud somewhere? Is that where trusted execution environments come in?
Yeah, so Fluence is basically similar to cloud solutions, but we can schedule these servers with tokens, with blockchains, and we could preserve ownership down the road. So it will be your own server, it will be your own cloud, but you won't be paying anything. It will be programmatically configured by Index, and thanks to Fluence and the all latency and all complicated things will be handled by the protocol. So you won't be hosting anything, you won't be deploying anything, you won't be monitoring anything, and it will be online like Bitcoin, how Bitcoin works, basically.
Yeah. So Fluence basically provides the guarantees so that you can have this trusted technology without having to have trust in humans to execute these things in a way that is also privacy preserving. I guess so. That's what you said. No data leakage, right?
Absolutely. So if you schedule trusted execution environment nodes, so that provides 100% privacy. Maybe, of course, there are risks. For example, the agent software might be malicious, but I think it has to be solved in different ways. Like if we want to, like the software itself might be dangerous, not runtime. So we protect the runtime, but let's say hundreds of agents. So one agent might be leaking data. How do we ensure this? There is no single solution. Unfortunately, there's no magic bullet to that problem. We think, again, reputation systems or staking systems are very important. Or, one agent might be understanding and security status of one code, and if you trust that code, it will be available to you. So autonomous security is also another approach to solve these problems.
Interesting. So I get the impression, so I'm just mapping this out in my head though, now, when an index is created, that can either be private or it can be something shared. Oh yeah, it says shared in the list there. And you had shared one starred in your list in the interface, right?
Yes.
And then those things can go into potentially privacy preserving data containers if necessary. Probably not necessary in the case of something that's shared, but then I can put I could actually index like all of my own private data if I trust the system enough to do that. And then when I'm combining or composing indices, doing searches, it could be, I don't know, maybe I've collected chat logs of me and everyone that I know at work, and I have an index that does this is a silly example again, but I'm full of silly examples. I have an index that determines whether or not someone is rude to other people, for example. So now I'm going to layer that over my like LinkedIn index that I created, and I could then do a query that says, show me all people who are interested in Taylor Swift and are also nice, right?
Absolutely.
Yeah.
That was a great example. And when you describe things, it usually clarifies for me too as well. Thank you for that.
I'm glad.
It is hard to explain, even for me sometimes, but thank you so much. So, but yeah, ultimately, the agents will handle all these privacy requirements, all these privacy settings according to your needs. Usually, ultimately, you're just going to provide your intent. You just want to say, I want to compose this data. I want to find these relationships between this data and that data if they exist. And that's all. Like just provide what you want to. Then agents will start, according to different indexes privacy settings, they will carry like the lowest privacy threshold. According to that, they will configure to like no data leak. According to these indexes, they will set up that required environment, and they will compete for relevancy, and you'll get your result. Hopefully, you won't have to deal with the middle points in there. I want to mention the next part of architecture, the agent runtime, like how agents are working in Index. That's, I think, it's also excites me a lot. So nowadays there are multiple agent frameworks, there are agent networks, there are agent tools, conversational agents, workflow-based agents. Now we do event-driven agents, and agents will be everywhere very soon. We truly believe the agent architecture because the agents are social algorithms. They can, by nature, they can collaborate. They can they are composable. They can talk with natural language, at least.
And when you're saying agent here, you're using the term generally the way the industry is addressing it right now, as well as specifically to your implementation, right?
Yes, exactly. So in Index, agents are positioned as event listeners or event processors. Similar to event-driven systems, you have a stream of data that continuously arrives new data. Then you process this data according to your logic, according to your reasoning. I think it's also a good concept to model human behavior, human cognition. You sense something, and usually you do something or you don't do something. So you have streaming inputs and you have discrete outputs and actions, behaviors. So this event model is like we didn't model. There's no model for agents. Agents are basically just processors according to their logic. So we just try to limit design, reduce design, and provide developers to just focus on their logic and focus on their agents. So
are they literally JavaScript functions or something different from that?
Literally JavaScript functions. I can easily show that. Sorry. Yes. So super quick. This is very simple agent boilerplate. So let's say we have an agent. This agent will have an identity, and we'll have different compute tiers. For example, standard, trusted execution environment, etc. And the permitted actions that agents can do. Agent can listen something, they can query indexes, maybe they can purchase something online. We don't know. So these are third-party actions should be available. Okay. Then what our agent can do, for example, where is it? Let me show. So let me show you through here. So when you run an agent, agents are basically starts listen something. For example, when I say I am curious about things, so then just we schedule a new agent, that agent listens. Let me run this agent if something new happens that's relevant to my curiosity, Sharef's curiosity. So they're listening all the new stream according to, in a contextual way. So similar to Apache Kafka or stream things like topics, but now you're subscribing to context. So now agents are functioning as contextual routers, contextual listeners. And over time, they can start new listeners. For example, if they are listening new developments in quantum technology, and if in new data they found a category theory, for example, they can start, I should also listen new developments in category theory. So like a bacteria, they can adjust themselves to areas that are more relevant to themselves and to process and listen new data.
Right. So what is that stream? Where are these events coming from? Is it a combination of indices that the agent has subscribed to?
Yes, exactly.
Okay.
Super quick. So, for example, right now we have a conversational setup. In this conversational setup, we have 27 indexes in here. So we subscribe all the index items, index events in these 27 indexes, and agents are basically processing all the new items according to relevancy to this context. So if it's relevant, they then run their logic here, and they might do an action or not do an action usually. So yes.
Yeah, cool. I like the Kafka example, or the general event message queuing system, because like you say, you subscribe to like a very static thing or like a wildcard pattern. But what here you're saying, subscribe to something based on some meaning. I imagine it could even be like you've created such a context that you could just say, subscribe to things you think I would like.
Yeah, exactly. Even like you don't have to define what you are listening, right? So, for example, I'm thinking about for products discovery. Show my products that relevant or potential customers. That's all. Like you don't even have to describe what you are going to do. Over time, by starting new listeners and canceling listeners, they'll find their way, ideally. Yeah.
Right. And this thing, to be clear, this is not an indexer. This is the thing such as whatever is running in the background that posted the message back to you about your update from Farcaster, right? It's a thing that processes the indices, but it's not the index itself.
Yes, absolutely. But action might be also indexing a new item. For example, let's consider an agent listens everything about blockchains and summarizing it and indexing under a summary index of things about, like, let's say, Taylor Swift perspective. So reading, interpreting according to its logic, and then indexing somewhere else. So like a fire hose, like a delivery stream. Indexes will be a destinations as well. Then maybe another agent will be listening that target index and index another thing. So it will be a very complex thing by just running 3 or 4 agents.
Right. And the creator of one agent might not have any idea how its output is eventually used.
Absolutely.
Yeah.
Cool.
That's really cool.
Thank you so much. Yes.
I have one last area of question for you. I mentioned a couple of times that the web interface that you were showing was an example of what you can build on the protocol, right? It's like it's the reference application, but it isn't the only application because protocols don't have one application, right?
Yes.
So I assume, therefore, I could build this application myself if I wanted, or I could build some headless thing or my own, like, I don't know, widget on a web page that uses this data. I'm just making up ideas. So am I right? And how do I do that?
Sure. Yeah, absolutely. You are right. You can build other applications. We already have seen, for example, another developer built this, Zagger. So Zagger is basically, it works like a social listening and programmatical funding tool built with Index. And the developer even didn't talk with us by building with this tool. So it listens, for example, I want to discover people casting about my company, and I want to automatically fund them. So another developer just built this. We're super excited about it. So what you can build, other apps, how we can build it. So we have 3 different concepts. The first one, you have an identity. We use the IDs for identity. We documented a lot, but please, if you're watching this, share feedbacks. We are super curious and trying to reduce the jargon. So we have index, right? Index itself, we have index item. So all the items can be index item. Then you can store embeddings. So you create an index, like just a basic CRUD function. Then you add an item. Then you store embeddings. So then your index functions as by itself, functions as a decentralized vector database. You can think of it, I think it's a good analogy. So you can, for example, it's a completions endpoint is pretty much standard these days. And now, instead of also, like, we have messages and prompt fields to query indexes. You can, discovery protocol is basically how you query. So completions endpoint carries message and prompt strings. You can interact with any prompt. But also you see there are sources field. So that's field basically index IDs. So you're asking questions to you're doing basic retrieval augmented generation to indexes from the developer-centric perspective. And the second part, the semantic listeners. Again, we also have sources field and the query field. You see, like to this index, I want to subscribe with this query if it's relevant to decentralized AI, and I will be getting messages if it fits to that criteria. That's the second semantic listener endpoint.
I want to inject one thing, because when we talked about this before, I remember you talking about composing all these indices,
Mhm.
And in my brain, as an old school developer, I was thinking, well, don't they have to have some sort of like, don't they have to have the same shape, like an API and a standard data type and all of this? And you showed me, no, you just add it to the source, and then you let the embeddings engine basically handle it, right? Which is really interesting. And to me, it was like, I think I even told you this when you mentioned, like, oh yeah, this is how APIs are going to work in the future, probably. It's going to be something like this, where as developers, we don't have to think about the Legos fitting together anymore, because that's what this layer is really good at already, right?
100%. Definitely. We'll definitely expose hybrid search endpoints. So the old school, the search functions, filters, and all these will be supported in the next releases. We don't give up, but we think it won't be useful. Like, we just work with LLMs and multiple. The competition will handle all the things, and embeddings are like, let's say, 5 different agents with embeddings. As you said, it's already enough and very useful to find these relationships. Absolutely. And also, like you mentioned, API design. Let's a bit talk about database design. So we have SQL, we have NoSQL, all these different databases, and these databases designed for developers. But so they have to be clear and very simple to allow humans to understand things. So that we have syntax, we have DSLs, and all of it. I think these concepts won't be necessary, because it will be machine to machine. So machine will be indexing and constructing data according to their preferences, and we will be leveraging. Like, let's say you have one data point, and right now you index from 5 different perspectives, like according to its relationship with one data. Then, so agents will attack your data. Agents will find all these relationships, and they won't be using a typical database. They will be just constructing different hash maps and sets, lists, and they will be stored on the fly. So index will be the first example. I think these kind of AI first databases, but more to come. I am also very excited about this space.
Mm-hmm. Yeah, fascinating. And so I guess, like, now if we zoom out, maybe to close to the very big picture of what you can do with this. Like, I look at it and I think I could write things that index data that I'm interested in. Like, I'm always fascinated by developer behavior, for example, and maybe the idea of marrying social media conversations about code repositories with GitHub repository activity, and then from there having an index of developers that I find interesting and being able to follow their activities, that sort of stuff. But these are like, this is my my brain being an IT developer at a company that wants to build a tool. But I'm realizing as we talk that if enough people are building these things and enough of them are public, then you can, like, slowly build these really deep slices into indexing data that's deeper than what happens. And of course, we don't know what happens behind the scenes at Google, for example, but it would theoretically be deeper and more domain specific, because each index would be, potentially really understanding the structure and the meaning of the data that it's indexing, and maybe creating something more than just embeddings, but a real knowledge graph under the covers, so that ultimately the searches and discovery that you do it could ultimately span the entire web, but do it in a way that's better than existing search engine technology, if you can incentivize enough developers to create these indices.
Well said. 100%. I agree. The data layer of index, what we call, is decentralized semantic index, and we are very proud of this definition. And we have decentralized indexes for blockchains, but now we have semantic index. So based on vector embeddings and also the indexed items, the summaries and entities and names and all of it, we are basically storing a new layer for discovery, an open layer for discovery. And it will be very open thing. So you'll carry with our perspectives, our biases, it will be all discoverable. So all the cultures will be discoverable, can be indexed. If you can index anything, it will be discoverable, that means. So cultures, perspectives, and what is best, what is good, and it will be very new, and that's really excites me. And like talking about decentralized semantic index, when I talk, I think we are pretty lucky by building these things.
Yes, cool. So I was going to ask you, is this ready? And I know, of course, there's a roadmap, but you already showed an example that someone built without even talking to you. So at least some parts of this are in production, and we can go build on it, right?
Yes, exactly. Some parts of right on production. Unfortunately, agents are now unfortunately centralized, but we are working hard to decentralize these parts as well. But you can store your data today in a decentralized way. You can query your data in a decentralized way. And we'll be integrating Index with large language model inference providers very soon, with multiple ones. Right now, we only have 2. But yeah, we are iterating quickly. Please test it. And if you have any feedback, happy to share. We are always available and love talking about discovery. Any kind of discovery question, happy to talk about it.
Okay. Well, thank you so much for the time. It was fun. I have found this topic to be interesting for literally decades now, and it's good to see someone building in this space.
Absolutely. Thank you for hosting me. I really enjoyed always talking with you. Really enjoyed. Thank you. Thank you so much, Chad.
Thanks.
Cheers.